Welcome to Oryx Learning. Today's lesson is on Unit 9, Volume and Surface Area, Lesson 6, Changes in Dimensions. Jamal's swimming pool holds 50,000 liters of water. He is going to build a new pool and double the dimensions of the pool. How much water will his new pool hold? If you'd like to find out the answer to this question, please follow along and we'll revisit it at the end. Solids are similar solids if they have the same shape and their corresponding linear measures are proportional. If solid X is similar to solid Y by a scale factor K, then the surface area of X is equal to the surface area of Y times the square of the scale factor. So K squared times the surface area. The surface area of solid Y is 6 times 1 times 1, or 6 units. K squared times the surface area would be 5 squared times 6, or 150 units. If solid X is similar to solid Y by a scale factor, then the volume of X is equal to the volume of Y times the cube of the scale factor, or K to the third times the volume. The volume of solid Y would be 1 times 1 times 1, or 1 units cubed. The volume of solid X would be 5 to the third times 1, or 125 units cubed. K to the third times the volume. What is the scale factor of the larger cone to the smaller cone in the picture below? The smaller cone is blank the size of the larger cone. If we're comparing the smaller cone to the larger cone, the smaller cone has a height of 4, and the larger cone has a height of 32. 4 over 32 reduces to 1/8, so the smaller cone is 1/8 the size of the larger cone. If the second cylinder is twice as large as the first, what is the height of the second cylinder? If the original height is 7, and the height of the larger cylinder is twice as large as the first, then the height of the second cylinder is 7 times 2, or 14. So 14 centimeters is the height of the second cylinder. The surface area of a rectangular prism is 78 square centimeters. What is the surface area of a similar prism that has dimensions 3 times as great as the dimensions of the original prism? Area is measured in square units. Therefore, scale factor is squared as well. If the scale factor for the dimensions of the prism is 3, then the area scale factor is 3 squared, or 9. So the surface area would be 78 times 9, or 702 centimeters squared. A triangular prism has a volume of 432 cubic yards. If the dimensions of the prism are reduced to 1/3 of the original dimensions, what is the volume of the new prism? Volume is a cubic measurement, therefore the scale factor is cubed as well. If the scale factor for the dimensions is 1/3, then the volume scale factor is 1/3 to the third power. 1 to the third over 3 to the third equals 1 over 27. So the volume is 432 times 1 over 27, which equals 16 yards cubed, or 16 cubic yards. So how is the volume of a prism affected when its dimensions are doubled? If the dimensions of a prism are doubled, the volume will be 2 to the third, or 8 times greater. So let's get back to our original problem. Jamal's swimming pool holds 50,000 liters of water. He is going to build a new pool and double the dimensions of the pool. How much water will his new pool hold? The dimensions are being doubled, thus the volume will be increased by a factor of 2 cubed. So the new volume will be k to the third times the volume. So the new volume is 2 cubed times 50,000 for the original 50,000 liters that were in the pool. This means that Jamal's swimming pool will now hold 400,000 liters of water. So Jamal's pool went from 50,000 liters. By doubling the dimensions, it now holds 400,000 liters. The perimeter of similar figures with scale factor of k is k times p units. The surface area of similar solids with scale factor of k is k squared times the surface area, SA, units squared. The volume of similar solids with scale factor of k is k to the third times the volume, units cubed. That is our lesson for today. Thank you for joining us, and I hope you enjoyed it.